Today I want to have a look at some basic electricity questions. Now, this is an opportunity to get using what we have been learning. Now, one of the most important things in this section would be the idea of there being electricity equations. Quite a few of them, if you think about it. We've got your Ohm's law here, we've got the movement of charge around a circuit, we've got how resistors combine, we've got various things involving power in electrical circuits. So there's quite a few equations in this section. We also have some rules that we have learned about how electricity operates in circuits. We have rules for series circuits, and we have rules relating to parallel circuits as well. So the idea that the voltages around a series loop add up to the voltage from the battery, and that the current is the same for all components in series. That the sum of currents entering any junction, where like electricity has to split up, equals the sum of currents leaving that junction, and equally when components are in parallel, that the voltage is the same. So current is the same when they're in series, voltage is the same when they're in parallel. And we get this sort of adding up case for voltages in a series loop, and an adding up case for currents in parallel circuits. So here we have an example. Resistances of 2 ohms and 3 ohms are connected in parallel across a 6-volt battery. Part A, state the voltage across each resistor. Now it says state, so that must be using some rule. So what do you think? Pause the video and see if you can think of a rule that gives you the voltage across these resistors. Pause it now. Okay, yes, well, we did say before that when things are in parallel, they have the same voltage across them. So the voltage across these two resistors will be the same as the battery voltage. So we can say that both resistors have the 6 volts across them. Part B then, calculate the total resistance of the circuit. So these are in parallel, we're told, so there's an expression and an equation, for that. Can you pause the video and have a go at calculating that for me? So we have that 1 over RT equals 1 over R1 plus 1 over R2, 1 over 2 plus 1 over 3, and taking a common denominator of 6, a half is 3/6, and a third is 2/6, giving us a total of 5/6, and that's 1 over RT, so RT will equal that upside down, which is 6 over 5, which is like 1 1/5 or 1.2 ohms. Part B2 then, the current in each resistor. Well, that's easy because we know the voltage across each resistor, and we can just use Ohm's law that if V equals IR, I is V over R in each case. So if we call this first one I1, we can say that I1 will equal 6 volts over 2 ohms, which is going to give us 3 amps. And if we call this other one I2, then I2 will equal the same 6 volts, but this time over the 3 ohms, giving us 2 amps. And part 3 is the easiest bit, the total current taken from the battery. Well, these two currents, I1 and I2, come from the 6 volt supply, so they come down from that branch coming from the battery here. So that both of these currents came down here. So we've got two currents leaving a junction here, I2 and I1. So I total here must equal the sum of I1 and I2. So that's going to be a total of 5 amps. So you can see here how we're using rules, things that are true, equations, and other things that are true. So it's the rules combined with the equations that give you a sort of logical set of steps. Resistances of 4 ohm, 6 ohm and 12 ohm are connected in parallel across a battery. A current of 2 amps flows from the battery towards the parallel network. Calculate. First of all, we want us to calculate the total resistance of this network. Okay, so this is a parallel set. We have an equation for that. So parallel combination, it's this equation. And it wouldn't matter how many resistors there were. This equation, as you can see from these dots, can go on and on. You can have R4, R5, etc. as long as they're all in parallel. So we need to fill these in. 1 over 4 plus 1 over 6 plus 1 over 12. And we need to take a common denominator, and that would be 12 in this case. So a quarter is going to be 3/12, a 6 is going to be 2/12, and a 12th is obviously going to be 1/12, and that gives us a total of 6/12. Now remember, that is not a value for Rp, that's a value for 1 over Rp. So if 1 over Rp is 6/12, then Rp is 12 over 6, which means the resistance of this combination is 2 ohms. Now they want you to work out the battery voltage and the voltage across each resistor. Well, we know that this combination is 2 ohms, so we can redraw the circuit. So we have a voltage V that we don't know. We have a resistance of 2 ohms, and we have a current of 2 amps. And so V equals IR is our Ohm's law equation. Have a go. And just pause the video while you have a go at that. So V equals IR, 2 times 2 gives us a voltage of 4 volts. Now it also mentions the voltage across each resistor, but again, as we said before, these are in parallel, so we already know the voltage across each resistor. So all the components in a parallel circuit will have the same voltage. So if we find the voltage across one of them, in this case the power supply with the thing that's causing the voltage, doesn't really matter. But if we can find the voltage somewhere in a parallel combination, we have found the voltage everywhere in that parallel combination. And lastly, they want the current in each of the resistors, and we can get that using Ohm's law. Okay, so have a go at those, see if you can get them. Try it first for the 4 ohms. Pause the video now, have a wee go at trying to get the current there. So the first thing we would do is give each current there its own little label, I1, I2, I3, and then we try and find I1 using Ohm's law. Now we know the voltage here is 4 volts, so the current in the 4 ohm resistor is going to be related to the 4 volts we've put across it. So I is V over R, which is going to be 4 over 4. So I1 is going to be 1 amp. I2 is going to be 4 over 6, which is going to be 2/3 of an amp. And I3 is going to be the 4 volts over the 12 ohms now. And that's going to be 1/3 of an amp. And what we notice is that these currents all go together to make the 2 amps that we already knew about. Because the current coming down from the battery has to split into these 3 currents, and so the 2 amps must be in these branches, which is why the currents in these branches still add up to 2 amps. A parallel combination of 2 ohms and 3 ohm resistors is joined in series with a 5 ohm resistor. The network is connected across a 31-volt battery. Calculate the current taken from the battery and the voltage across each resistor and the current in each resistor. So this is a combination circuit. It has a series bit and a parallel bit. Your first task would be to find the total resistance of this circuit. So see if you can do that. Pause the video and have a wee go at that. So if we call this wee parallel bit RP, then we can say that the total resistance will equal the sum of 5 plus RP, because the 2 bits are in series with each other. So if we can find that parallel combination, and then it's in series with the 5, so we can just add those. So we need to find that parallel combination. So stop the video and see if you can find the resistance of that parallel combination for me. So we use our parallel resistors equation. So 1 over RP is 1 over 2 plus 1 over 3. And taking a common denominator of 6, a half is 3/6 and a third is 2/6, giving us a total of 5/6. And that's for 1 over RP. So RP will be that upside down, which is 6 over 5, which is 1.2 ohms. So now we add that to the 5 to get the total resistance. So our R total is 6.2 ohms. They are interested in this total current. It says calculate the current taken from the battery. So that's this. And it's going to relate to the fact that we now know this total resistance. So Ohm's law will give us a resistance voltage current equation. So we need an I equation based on the resistance of this being 6.2 ohms. Have a wee go at that. So I total is going to be V over R total, which is going to be 31 volts over 6.2 ohms. And that works out to be exactly 5 amps. So what about the voltage across each resistor then? Now, by far the easiest way to do this is to say, well, this 5 amps flows entirely through this 5 ohms here. So we could use Ohm's law with the current and the resistance to get the voltage across this gap. See if you can do that for me. Pause the video. So V1 can be found from I times R, and we know that I is 5 amps and R is 5 ohms, so that must be 25 volts. Now we could do a more complicated calculation to do the same thing for RP, or a similar calculation by knowing the fact that RP is 1.2 ohms, so we could do V equals IR for that. Or we could just subtract what we've got here from 31 volts, take our 25 off that, and get 6. But we'll try it using this resistance just for the interest's sake. So V2 equals I times RP, which is 5 amps times 1.2 ohms. 1.2 is 1 1/5, and 1 1/5 fives is 6. And so as expected, these two voltages add up to the 31 volts. Now I've sort of run out of space for doing this last bit, but I'll talk you through it. Okay, they ask you to find the current in each resistor. Well, we know there's 5 amps here, so there's 5 amps in this first one, but that 5 amps splits here. What we can do is say, well, we know the voltage here, and if we put 6 volts across 3 ohms, we're going to get 2 amps. and so that means that there must be 2 amps here. If we put 6 volts across 2 ohms, we get 3 amps, and so there's going to be 3 amps in the top. We've got 5 amps in that first resistor, 3 amps in the 2 ohms, and 2 amps in the 3 ohms. Calculate the value of the current from the cell in each of these circuits. In both cases, we're expected to find the total resistance and then use Ohm's law to calculate the current. So have a go at that for this first one for me. Pause the video now, have a go at finding that total resistance. Okay, so that one's easy, isn't it? It's just the sum of the 3 resistors since they're all in series. So we get 2 plus 4 plus 6, which is 12 ohms. So now you use Ohm's law. Now you know that total resistance. You can use Ohm's law with the 12 ohms and the 3 volts to get a current. See if you can do that for me. Pause the video. Right, so I is V over R then. Well, V over R total. And so we've got 3 over 12. And that's a quarter, so it's 0.25 of an amp. Right, we need to do the same thing for the other one, so pause the video and find that total resistance. So we need our parallel equation for this one, and that means that 1 over Rp is going to be 1 over 8 plus 1 over 8. Now maybe some of you are looking at this and going, well, when there are 2 equal resistors, the answer is half of one of them. And yeah, fair enough, but we'll do this by the other method just for completeness. And so an eighth plus an eighth is 2 eighths. Now remember, that's an answer for what 1 over Rp is. So Rp is going to be that upside down, which is 8 over 2, which as we said before is 4 ohms. Now we need to do I is V over R for that. See if you can calculate that current for me. Pause the video and have a go at that. Right, so I is V over R. We've got 8 volts and we've got 4 ohms. So 8 over 4 is going to give us a current of 2 amps. State the voltage across each 8 ohm resistor in the second circuit. And again, it's state because you're using a rule. And we've talked about this rule quite a few times in this session, that when things are in parallel, they all have the same voltage. So everything in that circuit will have 8 volts across it. And so we can state that it's 8 volts, and the reason is that they're in parallel with the battery, which is 8 volts. Then, in each of the following circuits, calculate the currents I1, I2, I3 shown by ammeters A1, A2, A3. Calculate the voltage across each resistor. Again, what we do here is similar to what we've done before. We need to calculate that total resistance. Because they're 2 equal resistors, we can take a little shortcut here and say that 2 equal resistors here will have a parallel combination like this. Will have a resistance of 6 ohms because it's 2 12s in parallel. Now we can get the current by thinking about this being a 9 volts across 6 ohms. So see if you can put the 9 volts across the 6 ohms and get me the current I1. Pause the video and have a go. So I is V over RT, RT is 6, V is 9, 9 over 6 is 1.5 amps. Now this is easy because what will happen is that this current will split evenly between the 2 resistors. Or you can do Ohm's law for each one, put 9 volts across the 12 ohms, and you'll get a current. So putting 9 volts across a 12 ohm gives you 9 over 12, which is 0.75 of an amp. Or as I say, you can say this will split evenly, so you take your 1.5 and divide by 2 to get the same answer. So we can say that I3 also equals 0.75 of an amp. Splits evenly because they're equal resistors. Calculate the voltage across each resistor. Well, there's no real need to calculate the voltage across each resistor. This is really something you would state. These are all in parallel, and therefore they all have 9 volts across them. In fact, to be honest, that question doesn't make any sense, because we've already made use of the fact that there's 9 volts across each of these resistors. Not really sure what's going on there. Perhaps it's more relevant to the second question that we're going to look at. So this is the exact same question, it's just the ammeters are in different places. Task 1, we need to know this total resistance. So these are equal. So we've got 2 6s in a parallel combination, so that's going to give you a 3. 2 4s in a parallel combination is going to give you a 2. So we can think of that as being a 3 and a 2. So if I redraw that circuit, then you've got a circuit like this, which basically the 3 and the 2 means the total resistance of this is going to be 5 ohms. Stop the video and see if you can work out this total current based on the fact that we now know that the total resistance here is 5 ohms. Pause it and have a wee go. Right, so I total is V over R total, which is going to be 10 over 5. And that gives us an I total of 2 amps. Now what's going to happen is that when this 2 amps comes down, it's going to find 2 equal resistors here. So it's going to split evenly through them. And the same thing when it gets back to here, it has to split again, but evenly because they're equal. So that means that this is going to be 1 amp, and then it goes back to 2 here, and then this is going to split into 1 amp, 1 amp. So we've got 1, 1, 1, 1. So the answers to A2 and A3 are going to be 1 amp and 1 amp. So both currents I1 and I2 are going to be 1 amp for that reason. Now, if you wanted, you could look at the idea that there's a 3 and a 2 here, and you could work out the voltages across the 3 and the 2 based on the fact that you know the current. If you know the current here is 2 amps, then you can put that current through the 3 ohms and see what voltage you get, and then put that current through the 2 ohms and see what voltage you get there, and then you can take that voltage back to the... So if we put 2 amps through the 3 ohms here, then Ohm's law says V equals IR, so there's going to be 6 volts across this. 2 amps through the 2 ohms, there's going to be 4 volts here. So you get 6 volts across this pair, 4 volts across this pair, and then you can put that voltage across one of these, well actually this one. So if we've got 6 volts here, 6 ohms, we're going to get 1 amp. And if we've got 4 volts here across 4 ohms, we're going to get 1 amp. So you can do it that way as well. So there's lots of different ways of getting the results here. It's basically just combinations of the rules of how current and voltage behave, combined with our knowledge of Ohm's law. So hopefully that wee run through has helped you with your nerves about answering electricity questions in exams. Thanks for watching.